8.2 is the section called Exponents and Order of Operations in Variable Expressions. So we're going to do a little review of exponents, which we've talked about before back in section 1.9. The first problems here say to simplify, and we have a fraction, and it's 8/9 and it's being squared. So if you recall, all this means I'm going to do is I'm going to take 8 over 9 times another 8 over 9. And so I'm going to multiply straight across. 8 times 8 is 64. 9 times 9 is 81. And we've simplified our expression. Similarly, for 1/5 to the third, since it's to the third, we're going to multiply 1/5 by itself 3 times. So 1 times 1 times 1 is still 1. 5 times 5 times 5 is 125. So again, when I'm simplifying an expression that has exponents, essentially all I'm doing is I'm multiplying that number by itself as many times as my exponent is asking me to do. Okay, so let's take a look a little further down here, and we'll look at the order of operations again. And so again, we've talked about order of operations before. They're the same exact order of operations we did also back in 1.9. So if you notice, it says we're going to perform all operations within parentheses, brackets, or other grouping symbols, such as fraction bars, and we're going to start with the innermost set. So remember, that means we start from the inside out. Number 2, if we have any exponents, we'll go ahead and deal with that. Then we're going to multiply or we're going to divide, depending on which one comes first, and we need to go in order from left to right. And the same thing for adding or subtracting. We will do whichever one comes first as we go from left to right. So I notice my first problem here, I do not have parentheses, so I don't need to worry about number 1, but I do have an exponent. So my first step is going to say, okay, well, this is 6 divided by 3 plus 5 squared would be 25. Now I do have some division, so 6 divided by 3 is 2 plus 25, and I finally add those numbers together and we come up with 27. Okay, let's try the next one. So again, here I have 20 divided by 5 times 4. Again, I don't have any parentheses, I don't have any exponents. I do have multiplication and division, but remember, I need to do whichever one comes first from left to right, and the first thing I see is that division. So 20 divided by 5 is 4 times 4, and 4 times 4 is going to give me 16. Alright, let's keep moving along here. So in the next problem that I have, it's 1 plus 2, and then brackets 5, parentheses 2 times 3, plus 1, close my parentheses, minus 10, and then close my bracket. Okay, so again, we're going to go slow with this problem. I'm going to leave the 1 plus 2 alone. I'm going to leave the 5 alone. I need to do what's on the inside of my parentheses first. 2 times 3 is going to give me 6, plus 1, minus 10. So now I have 1 plus 2. I still have parentheses. 6 plus 1 is 7. Remember, that operation there now, guys, is multiplication. Okay, I'm going to come up here where I have a little bit more room. So I have 1 plus 2. My brackets, I need to do 5 times 7 first. That's 35. Minus 10. So 1 plus 2, 35 minus 10 is going to give me 25. Again, that's multiplication there because my 2 is right in front of my bracket. So now I have 1 plus 2 times 25 is 50, and 1 plus 50 is going to give me 51. So again, if you notice, in every one of these lines, I'm only doing one step, right? One step at a time. Let's try the next problem here. We'll go through it together. I have a fraction bar, so I'm going to take care of the top, and then we'll come back and take care of the bottom. 6 minus 4 is 2, and 9 minus 2 is 7. I can't simplify that, so we're done. In the next problem that I have here, again, I'm going to simplify my fraction. I'm going to take care of the top. So I have 19 minus 3 times 5 is 15. I'm going to continue to work with the top. 19 minus 15 is 4. Now I'll come back and do the bottom. So 6 minus 4 is 2. And then finally, my last step is just to go ahead and divide. 2 goes into 4 2 times. All right. Let's try this next one here. So again, I'm going to take care of the top. So I'm going to leave this first 3 alone. Plus 3. I'm going to go ahead and do what's on the inside of my parentheses. 5 plus 3 is 8. Remember, that means I'm multiplying here. So I'm going to continue here. That's going to be 3 plus 3 times 8 is 24. Okay. And 3 plus 24 is 27. Now let's go ahead and take care of the bottom. So on the bottom here I have 3 squared plus 1. I need to do my exponent first. 3 squared is 9 plus 1. 9 plus 1 is 10. And I cannot simplify 27 over 10. And so again, that there will be my final answer. All right, so the next part we have here is dealing with the absolute value. And it says the absolute value of a number is the number's distance from 0 on the number line. And the symbol for absolute value is this symbol right here. So it's like 2 bars. Okay, so the first thing I want you to notice is that we're talking about the distance. And the one thing I want to mention about distance can never be negative, okay? So think about it. Either you decided to go jog 2 miles today or you didn't, but you couldn't say I jogged negative 4 miles, right? That wouldn't make any sense. So I want to point something out here. I'm going to draw a number line sort of right here. And forgive my crude drawing, but here's 0, say 1, 2, 3, 4, right? And negative 1, negative 2, negative 3, and negative 4, okay? And so we're going to figure out, I'm going to kind of extend that a little bit, maybe a little bit over here too. So I know somewhere over here would be the number 7. If I was trying to find the distance from 7 to the 0, I would just sort of count how many spaces do I need to move to get back here, and I would say, well, 7 spaces. And even if I was doing negative 8, I would have to count, look, 1, 2, 3, 4, 5, 6, 7. It would still be 8 spaces because I'm counting the number of spaces, right? And then for the next one here, it says, what's the absolute value of 0? Well, how far is 0 away from 0? Well, we're already right there, so we don't have to worry about any sort of distance, okay? Now, the next couple of problems we have here are asking us to evaluate. And anytime it tells me to evaluate, essentially what I'm doing here, guys, I usually call this plug and chug, because what I'm going to do is everywhere I have the letter X, I'm going to plug in the number 1. And in my first problem here, I see I have the letter X, so I'm going to say 3 times 1 minus 2. I need to do my multiplication first, so 3 times 1 is 3 minus 2, and 3 minus 2 is just 1. I'm going to do the same thing in the next problem. So again, everywhere I have the letter X, I'm going to put my number 1. Where I have my Y, I'm going to put my number 3. And where I have my Z, I'm going to put my number 5. Okay, so again, I'm going to do my multiplication first. 1 times 3 is going to give me 3. And 3 plus 5 is going to give me 8. So this is why I call them plug and chug. I take my values for my variables, I plug them in, and then I sort of chug along doing whatever sort of operation I need to do. Let's try these next couple over here. So again, here it also says evaluate each expression. And again, it gives me some values. X is equal to 12, Y is equal to 8, Z is equal to 4. Okay, so my first step here, where my letter Y was, I'm going to put my number 8. Where my letter Z was, I'm going to put my number 4. Plus 8 times where my X was, we had a 12. So I'm going to go ahead and do my fraction. 8 divided by 4 is 2. 8 times 12 is going to give me 96. And 2 plus 96 is just going to give me 98. All right. And so for the next one here, I'll do it the same way. I'm going to write parentheses. I'm going to write my number 12 because it's going to be squared. Minus 3 times where my y was, we're going to put our number 8. Plus we have an x, and we said x was the number 12. So I'm going to go ahead and take care of my exponent. So 12 squared is going to be 144. Minus 3 times 8 is going to give me 24. Plus 12. Okay, so I know that 144 minus 24 is going to give me 120. And 120 plus 12 is going to give me 132. All right, so the next part of 8.2, we have this table here. And this table is giving me all the words that mean either add, subtract, multiply, divide, or gives me the equal sign. So I want you to sort of take a look here. These are all the words that mean to add. So sum, plus, added to, more than, increase by, and total. These all are all the words here that mean to subtract. So the difference of, minus, subtracted from, less than, decrease by, or less. The words that mean multiply are right here. So product, times, multiply, twice. Twice obviously means to multiply by 2. And the word of. And let's see, division would be these here. So quotient, divide, into, ratio, divided by. And then for equals would be these words over here. So obviously equals, gives, is, was, or should be. Yields, amounts to, represents, and is the same as. Okay, so let's take a look, and it says write each phrase as an algebraic expression. Let x represent the unknown number. So anytime I see that phrase, the number, I'm going to use the letter x. So the first part says 15 more than a number. So I'm going to go ahead and write down my number 15. More than means I'm going to add. A number means I'm going to put the letter x. Good. 5 decrease by a number. So I'm going to go 5. I can see decrease by is under subtraction. So minus a number. The ratio of a number in 4. So if I look for ratio, here's ratio here under division. So I'm going to write my number, which is x, divided by 4. So the order in which you see them is typically what we end up writing. There's a couple of sort of special cases when we need to write it in a different way, and I'll show you if we have one like that. Okay, so we got a few more here. Let me fix that there. There we go. Okay, the quotient of a number 9. If you go back and look at that table, you're going to see quotient under division again. So that's going to be x divided by 9. Okay. The next part here says 3 times a number increased by 22. So 3 times the number, 3x. Increased means to add 22. Okay, so one thing I want to point out here, these here that we just did are all expressions. If you notice, I'm just writing it out. I don't have any sort of equal signs other than the one that I'm putting here, like the quotient of a number 9 is, or equals here, x divided by 9. But I don't have an equal sign in the sense of my problem. Now, the next part here says, write each sentence as an equation or an equality. I believe all these here are going to be equations, so I'm not going to worry about the inequality. And it says 1 increased by 2. So 1 increased by means to add 2 equals the quotient of 9 and 3. So it's there's an equals in my phrase. So that's what we call an equation. Okay. The sum of 5 and a number is 20. Okay, so sum. So 5, sum means to add. A number is means equals 20. 7 subtracted from a number is 0. So 7 subtracted from a number. So since I'm subtracting 7 from a number, I need to go x minus 7 is means equals again, and 0. And then finally the last one here says 8 added to twice a number is 42. So 8 added to twice a number is 42.